Today we will discuss about how BERT works, its fundamentals and its programming. In today's video we are going to do email classification using BERT. Now BERT will convert the whole email into an embedding vector, and that is something we can feed into our neural network and train the model. So it will generate a vector of 786 length, and then we will supply it to a very simple neural network with only one neuron in the dense layer as an output. Will also create a dropout layer. Now BERT has only two components, preprocessing and encoding. Let's code BERT model in Python. First we will import a few necessary libraries. Import TensorFlow as TF, import TensorFlow hub as hub, import TensorFlow underscore text as text. Let's read our data into a pandas data frame. Import pandas as PD, df equals pd.read underscore csv, spam.csv, df.head file. Let's take a look at our data classes to see if there is any imbalance. df.groupby, category.describe. Now let's deal with the imbalance by downsampling. As you can see, 15% are spam emails and 85% are ham emails. What we will do is we will take 747 ham emails and discard the rest of them. Now this will of course be wasting our training data, which is not good for our training, but for simplicity's sake we are using downsampling. df category.value counts 747 divided by 4825. Let's equalize the class imbalance. df underscore spam equals df category equals spam, df underscore spam dot shape, df underscore ham equals df category equals ham, df underscore ham dot shape, df underscore ham underscore downsampled equals df underscore ham dot sample, df underscore spam dot shape 0, and this will give you the downsampled data set. Now we have to combine it into the balance data set. So df underscore balance equals pd dot concat df underscore ham underscore downsampled comma df underscore spam and df underscore balance category dot value counts. Now we downsampled by first equaling the ham and spam and then concatenating both subsets to create a new data set. Now we need to create a text target column into a binary encoded ham or spam column. To do so, df underscore balance spam equals df underscore balance category dot apply lambda x if 1 colon 1 if x equals spam else 0, df underscore balance dot sample 5. Here we're just declaring that if x, which is our target records, are spam, then encode them as 1. Otherwise, if it is ham, then encode them as 0. Now with our data frame ready, we need to implement train test split. From sklearn.model underscore selection, import train test split, x train x test y train y test equals x train underscore test underscore split, and df underscore balanced message, comma df underscore balance spam, comma stratify equals df underscore balanced spam. We will use stratify so that the ham and spam is equal in our test and train sets. Now we will implement BERT. Let's first declare our preprocess and code layers with their URLs. BERT underscore preprocess equals hub.keras layer https colon tf hub.dev tensorflow BERT and which is simply the link URL of the BERT preprocessing, and BERT underscore encoder equals hub.keras layer and the URL for that. It will take a while because it is downloading the model locally on your computer. Now let's write a simple Python function that takes the message and an output and returns a vector as an input. Def get underscore sentence underscore embedding sentences colon preprocess underscore text equals BERT underscore preprocess sentences, return BERT encoder preprocess text pooled output. Get sentence embedding $500 discount, $500 discount, hurry up in double quotes, and Bhavin, are you up for a volleyball game tomorrow in double quotes. Now let's get word embedding for some random words. E equals get sentence embedding banana, grapes, mango, Jeff Bezos, Elon Musk and Bill Gates. Here E is the embedding of all the above words. You would think that the first three words will be similar to each other as they are fruits and the last three to each other as they are entrepreneurs. From sklearn.metrics.pairwise import cosine similarity E0 E1. Now let's create a functional neural network. BERT layers text underscore input equals df.keras.layers.input shape equals empty d type or data type equals df.string comma name equals text. Preprocessed underscore text equals bert dot preprocessed text underscore input. Outputs equals bert underscore encoder preprocessed text. Neural network layers. L equals tf dot garage dot layers dot dropout dot 1 name equals dropout. Outputs pooled output 1 equals tf dot garage dot layers dot dense 1 activation equals sigmoid name equals output. Model equals tf dot garage dot model inputs equals text input outputs equals 1. Now let's get our model summary. So model dot summary. Now let's check our model scores, accuracy, precision, and recall. So metrics equals tf dot garage dot metrics dot binary accuracy name equals accuracy. tf dot garage dot metrics dot precision name equals precision. tf dot garage dot metrics dot recall name equals recall. Model dot compile optimizer equals Adam. Loss equals binary cross entropy, and metrics equals metrics. Now let's fit our model and evaluate on the testing samples. Model.fit x train, y train, epochs equals 10. Model.evaluate x test, y test. Epsilon.metrics, import confusion matrix and classification report. Now let's build a confusion matrix. Cm equals confusion matrix, y test, y predicted. Cm from matplotlib import pyplot as plt, import cborn as sns, sns.heatmap cm, and not equals true. This is simply annotations. fmt equals d, plt.x label predicted, plt.y label true. Let's just get a classification report. So print classification underscore report y test, y predicted.